But before we dive in, can I get a show of hands? Who of you has a team dedicated to working on app performance? That's a couple. Who of you has a single person dealing with this? Who's thinking about doing stuff with performance? And who does nothing with app performance at all? All right, after the session, you know what you need to do to get going. So let's start. Why are we doing this? If you don't do anything with app performance, you can have a really bad experience. You can wait for content. Sometimes scrolling can be really janky, and your app might even crash. This is the bad experience, and you don't want to have this. And we'll show you how to get from the bad experience to the mad experience. That means the app launches really fast, you have a smooth experience throughout, and it's a delight to use. So today we're showing you how to get from here to here by introducing you to what we call the modern app performance cycle. You get started by looking at what's going on, inspecting your app, and then you improve it. And after you improve that, you go into monitoring and see what happened. And then you continue. That's why it's a cycle. But why should you care? Not just from a user perspective, but a business perspective. We've worked with a lot of partners to figure this out. Zomato is a large Indian restaurant aggregator app. They also deliver food with over 43 million active users and more than 1.5 million orders a day. They're quite big. And they improved their app startup time by an average of 30%. According to Zomato, this led to an increase in day one user retention of 90% and more than 600,000 more orders over the time that they observed, which is quite dramatic. They did this by removing unused libraries, using the app startup library, doing lazy loading for images and code, overhaul their view strategy and their layout strategy. OK Credit is another company that we worked with. It's a bookkeeping app for small businesses. And they inspected and monitored the app performance with Android Studio profilers and Android Vitals and found a lot of areas to improve. While doing that, they managed to reduce their unresponsive app states by more than 50%, which increased the user retention by more than 20%. They did this by moving hot code paths out of the main thread and reduced the image file size. They optimized layout inflation and using view stubs and async layout inflators. OK Credit saw the user retention increase by at least 20% and had an increase in transactions of more than 30%. Again, we see focusing on performance can have a very clear and direct and significant impact on your user experience as well as your business metrics. Let me give you one last example. The Google Maps team improved their app startup time by another 30% after introducing a new technology called baseline profiles. It's a new way to speed up your app launch and hot code path performance. This improvement led to an increase in searches of about 2.4%. And at the scale of Google Maps, that, again, is a dramatic change. We're going a lot deeper onto baseline profiles later on. But spoilers, it's ready to use, and you should be starting to use it right now. Some of you said you don't do anything for app performance. It's actually not quite true. If you build, you already do some things. Let me show you what you do. There is the holy trifecta of updates, which is new features, bug fixes, and performance improvements. And while this is very abstract, it's actually true. If you update your libraries that you're using within your app, you get all these things for free, because you don't have to do any work other than, well, doing the update. If you use Gradle, you basically have the possibility to shrink your app's resources by setting this flag to true. That means unused resources and resources get shrunk into a size that is more digestible by the user and saves more space on the user's device. You can also set minify enabled, which enables R8, turns on obfuscation and code shrinking. Usually that's used in release builds by default, and it comes with our templates anyways, so you should be using that. This shrinks the code, removes unused code, does tree shaking and a couple of other things that help you have a more performant application in the end for your users. And you get to improve that even further by using things like ProGuard. With a default configuration, we provide 2 different ones, and you can add your own program rules if you're a library or an app developer. There's one thing that you get absolutely for free, and that is Google Cloud Profiles. You get these by uploading your application to the Google Play Store. Google Play sends the app to your user when they request it, and then start using the app. When they do that, we gather anonymous usage data, and that report that back to the Google Play Store. And after of that, we generate baseline profile rules, which are being shipped through the Google Play Store back to other devices. So that means there's a list of methods and classes that we can find out with that can be optimized and ahead of time compiled. That full list is then bundled into the APK, and when a new user comes along, that just gets sent to that user as well. So this means the performance of your application is improved as soon as this happens. But because this is aggregated after the app is installed for the first couple of users, every new update, generating one of those profiles can take a while, sometimes up to a week. So that means for that first week, users might have not the most optimized experience. The cool thing about this, though, is all you have to do is upload your app to the Play Store, and you get all this for free. So now you know what you're already doing. Let me talk to you about what you should be looking out for. There's a lot of things that you should be looking out for with the metrics, and let's get going with that. So the key performance metrics are very far-reaching. There's app startup, which means your app should start smoothly and fast. There is overall smooth experience, which is being responsive to clicks, being responsive to scrolling. Also, your app should be power-saving, should be smart with data usage. The app size should be as small as necessary and possible, and it should be crash-free. That's a lot, and we don't have that much time, so today we'll just focus on app startup and a smooth experience, because these two can have massive impact on your users, on your app, and on your business. We're starting off with app startup. This is where the user first interacts with your app. It should be fast, it should be smooth, and should provide a nice first impression. In performance terms, we're looking at startup in 3 different phases. There is a cold start, which is when your app starts fresh. There's a warm start, and there's a hot start, and these basically come in one big cycle. So cold start essentially means when your app is created, when the process is created, which is starting with application on create, and goes on from there until your app is ready to use. A warm start starts when the view hierarchy is being inflated, which is basically your activity on create, which happens when your app is being torn down and when the activity is being torn down and recreated due to orientation changes or any other things that make the activity being recreated. And there's a hot start, which essentially is just is when the first frame is being drawn, and that is the point where your activity is just being restarted after being in the background briefly. This is where one of the key metrics comes in. This is time to initial display. Time to initial display means the first frame is ready to be drawn from the app start. This time should be very short, very fast, and in your log, you see this with the Activity Task Manager displayed, so that's what that means when you've seen that and wondered what it should mean. And on top of that, there is time to full display. Time to full display means that your content is ready, and the Activity Task Manager shows you that by showing fully drawn. This is a state that you have to find yourself. It means it is reached when your data has been loaded, when the app's content is ready to be displayed. It's not necessarily a specific frame in that time, but it's best effort when enough data is loaded so the user can start interacting with your application. This can't really be automated, so you have to know when the user can take over and start using the application. And that's why we have an API for that. That API is called Report Fully Drawn. It is used to inform the framework that the app is ready to use, and it can be used to create further performance improvements for you. The second metrics that you should be looking out for is what we need to create a smooth app experience. This means not dropping any frames. And in order to not drop frames, you need to know about frame rates. We used to know and talk about 60 frames per second, which gives you 16.67 milliseconds, or 1/16th of a second to create stuff on the main thread, do things in order to not drop frames. Now there's 90 frames per second, which is 1/90th of a second, and there's even devices like Pixel 6 Pro that have 120 frames per second, which makes things really, really fast, and this gives you a very, very short window to do things on the main thread. So these new devices create faster refresh rates. And what are we looking out for? We used to look out for 60 frames per second, but now we recommend you to optimize for at least 90 frames per second. And the best way to get this is, the best way to fit all the UI work in this frame is by staying off the main thread. So do this, and you're able to get going with all your metrics. We can get to improve all your smoothness in the first place. With that, let me hand it to Thomas.
Thanks. So now that we've seen the metrics we should look out for, it's time to inspect performance. But what do we actually mean by inspecting performance? Inspecting performance, understanding what's happening in your application, and making sure it aligns with what you expected. There are three ways how to inspect performance. First, passive. It's kind of like, can you spot the problem? And we do the things for you. Then there's manual. If you were being able to spot the problem, now it's the time you can debug that. And then there's automated. And automated, you can even prevent a similar problem in the future. Let's talk about passive. So passive way is you can see in a logcat when there's a jank or something. First of all, you can see it visually that something janked. But also in logcat, when you check for the choreographer tag, it'll tell you there was some amount of skipped frames. And it will happen when there was at least 30 frames skipped, which means, as Ben was saying, when there's 90 FPS, it's just 333 milliseconds, not that long. If it was even longer, if it was longer than 700 milliseconds, then OpenGL renderer will call Davey, and it'll be like telling you the duration and more information for that. And that we call frozen frames. And if it's even longer than 5 seconds, then we see that kind of dialogue. I hope you didn't see the dialogue for a long time. That was for jank. But what about app startup? App startup is kind of harder to spot visually because, well, the startup kind of holds on one frame. But for that, you can check also logcat with Activity Task Manager, as Ben was saying, and you can look out for the displayed, and it'll tell you every time you start an activity, like how long did it take to start your activity. And if you call the report fully drawn, it will even tell you like how long that took. So if you don't do anything and you want to understand like how long does it take to start your app, you can just filter the logcat and see the things. Although you probably see the performance problems in development where you may spend the most time with your application, and even on Android emulator. And although Android emulator has many cool features and it's a really cool use case for iterating quickly and developing, measuring performance is not one of the use cases. Because basically, emulator shares the resources with the other applications on your system, on the hosting machine. And therefore, if you have many things running, the performance of your application will be worse. So it's not really saying what the performance was. So don't measure things on emulator. But also, if you see a problem in development, that means you're probably using debuggable flag. And debuggable flag allows to do things like live edit and attach debugger and see things where you need it when you develop. But again, it's if you want to measure performance, if you see it in debug, make sure that you verify it in release mode when you don't set the debuggable. It would be nice if you could that with a build type or something which is as close to possible what you ship to your users. All right, so we've we've spotted it maybe. Now, can we reproduce the problem? If we can manually debug what's happening. For that, we can use Android profilers. Profiler is kind of like a debugger. So when there's a problem with the code, a code execution problem, you use debugger. When there's a performance problem, you can use profiler. But as I was saying before, since you want to verify it in release, not debuggable mode, it's not possible by default. For that, you need to use profilable tag in your Android manifest. This tag is available since Android Q, and it allows to measure the performance, attach some of the profilers to your application while doing release. OK, so first step so you can debug performance is system tracing. System tracing lets you collect and examine timing information for everything that's happening on your device, not just your application. And it helps you understand what is your app doing and when. So you can see things that are taking longer than you might expect. So there are 3 ways how you can start system tracing. The first one is you can attach it to the current session. So basically, you run your application, hopefully in the release mode, and you start the profile pane, and then you just click the plus and attach to your session, running session. And then you interact with your application, and the system trace can be recorded. But there's a caveat here. If you want to measure app startup, you can't do that with this, because app startup would need to wait for the profiler to attach. So for that, to measure app startup, you can go into the run configurations, and in the profiling tab, you can check the mark, start this recording on startup, select system tracing, and next time when you build your application with profile, it'll wait for the profiler to be attached, and you can measure the system tracing for the app startup. It's kind of like similar as you would attach a debugger on startup. And there's even third option to run system tracing, and that is helpful when you, for example, see a problem with the production version of application, and you're not at your workstation, so you're somewhere out, and you're like, oh, there was a jank or something. So you can go into developer settings, and you can click the system tracing, record a trace, and then interact with your application, stop the trace, and the trace will be saved on your device. And later on, you can share it with the development team or yourself so that you can check it on the workstation later. All right. So now that we've recorded the trace, we can load it in Android Studio. I know that there's a lot of happening. So let's look at the sections on the system trace. So on the left side, you can see the list of threads that were happening during the system trace. You can see also, so there's the first one, the first line, this is the main thread. It'll have the name as the same as the package name of your application. And then you can see the various trace sections with the naming and timing. So you can more investigate what is happening. So we can see like bind application, this is where your application is starting. There's perform create, it's like what activity on create does, perform start, and etc. On the right side, you can see the list of the that took the longest during the system trace. So we can see there's even the bind application, as I was saying. And there are even different ways how to look at it, like from the top down or flame chart, so you can investigate more. If you run the system tracing on a device on Android 12 and higher, there's a new feature called jank detection. And it basically allows you to, when you run a system trace, it allows you to see the frames that were janky, that took longer than expected during the system trace. And you can even click on that, and on the timeline, you can see it visually that, oh, here was some jank, so you can easily investigate what was happening. If you click on that trace, you can see like what work was done during the execution of that specific frame. So you can see, all right, I now need to investigate that something took longer than expected. But oftentimes, there won't be enough information. And if you want to have more information in the system tracing, you can. The first step, what you can do is add Android X tracing library to your application, and then use the trace function from that library with a custom name as a parameter. And basically, you can wrap any code in your application, and once you later run the system trace, it'll have these sections in the system trace. So now you can see, like, even with bigger detail, what happened. The other way is, like, if that's still not enough, if you want more, which is obvious, you can use call stack sampling profiler. Call stack sampling profiler allows to measure all of the stack traces that happened during the trace, but it adds a little bit of overhead. So make sure to run first system tracing to know where to look at. We've got a cool math skills series videos right on that topic, so you can check that. Okay, now we've manually measured performance. Let's automate it. We can automate performance with benchmark, performance inspection with benchmark. To start with that, we can use Jetpack macro benchmark, which recently went stable. This library automates performance debugging of the entire user flows, such as app startup, scrolling, or like navigating within your application, or stuff like that. It allows it does it repetitive measurements, so it can prevent or avoid, sometimes there may be a performance fluke. So since it does in a loop, it can prevent that. How to get started with macro benchmark? To get started, we provide, an Android Studio provides a module wizard. So you create a new module, select benchmark and macro benchmark. You will fill in the details for your application, hit OK, and it will provide you a great out-of-box experience. What it does is basically add a new module, a testing module, and it adds an additional build type that mimics the release build type of your application, but it adds debuggable key stores, so you can build it locally. So as I was saying, you can mimic the release performance locally. And then you basically write a instrumentation test. So you create a class, annotate, run with Android instrumentation, and then you use, from that library, you use macro benchmark rule. And so let's write a startup test as here. So in the startup test, we'll use benchmark rule and the measure repeated method. Inside that method, we need to specify a couple of parameters. So let's go over them. First, let's specify package name. So the benchmark library runs out of your application process, so we need to specify which application to interact with. And the reason for that is that macro benchmark can stop, start, reinstall, recompile the ahead-of-time compilation of your application, so that's why we run out of process. Next, we specify metrics. So we want to measure app startup, so we'll use startup timing metric. But there are more. There's frame timing metric that allows to measure the duration of every single frame that was created during the benchmark and allows to find jank in your application. But there's even more. There's trace section metric that allows to measure timing of any custom metric. So as you've defined the metric before, the trace section before, you can measure it with this one. Or you can even measure audio underrun while playing audio. And there are going to be more. Next, we specify number of iterations. This basically means, as I was saying, that it can avoid the potential performance fluke. So if you choose bigger number, there's like bigger chance to avoid any performance problem, but at the cost of higher execution time. This number, the ideal number, will kind of depend on how noisy the particular metric is for your application. And then we specify startup mode. Here is basically what Ben was saying, cold, warm, or hot. We recommend starting with cold. That takes the longest time, the most work for your application to do. And warm or hot is helpful when you have some kind of caching mechanism in your application and you want to measure that as well. And then we add measure block. So this Lambda parameter, this is the place where you interact with your application. And since I was saying this is out of process, we will use UI automator to interact with the application. So first, we'll use a helper method, press home, that will reset the state of your device to the home screen, so that if the device were somewhere in the middle of flow, it's like right on the home screen. And then we can use helper method start activity and wait. So this method basically starts the default activity of your application, and it waits until the first frame is rendered. So this way, you can measure time to initial display, just with the two method calls. If you want to specify a different activity, you can add an optional intent parameter. What about time to full display? For that, we need to wait for that to happen. So if we call report fully drawn, we need to wait until the state is similar as when you call the report fully drawn. So we'll use device wait until some object is on the screen, and then we could use by some resource name. So for us, it will be feed content. And now we've measured time to full display. OK, so we've got a benchmark ready. Let's run it. But as I was saying before, we should run it on a real device, not on an emulator. Once you run it, the benchmark will start, stop the activity, it'll run the interactions, and then it'll provide results. So the results are first to Android Studio output, and also as a JSON file, so you can parse it on CI and have like a nice charts and stuff to prevent regression. And here we see, so time to initial display, that we get like the minimum value, median, maximum. So basically, it is the normal distribution of the startup times during the iterations. And the same, so that's time to initial display, the same for time to full display. All right, we've measured up startup. That wasn't that hard. So what about improving the performance? So we've debugged it. We found some problem. And to improve the performance, well, the obvious thing would be if you found something that took longer, then you now could fix it. But we will now improve performance for every one of you without fixing the problem you found. We'll improve it with using baseline profiles. And as Ben was saying about cloud profiles, these are cool, and they are for free for you without doing any work, but they tend to take some amount of time until they aggregated and generated. So what if, instead of waiting on cloud profiles, you could generate basically the same rules on your computer for your application, or you could do that also if you develop an Android library, so you can generate the rules for your library, and then upload the application with the generated rules into Google Play. Google Play will process the profiles, and then when users download the application before the cloud profiles are ready, it will basically use the rules you specified so that they get the performance boost out of the box. And at installation, Art will basically pre-compile the rules, which are the methods or classes, into machine code so that when you start your application, it doesn't have to wait for the just-in-time compilation to pre-compile those methods. So you get the performance benefits. All right, generating a profile. Let's generate a profile. For generating a profile, we can use the same library, Jetpack Macro Benchmark. But this time, so we'll write another instrumentation test, but this time we'll use baseline profile rule. And so let's use that rule, and let's write a generate method. Inside that method, inside that test, you'll call collect baseline profile method. And it accepts, it requires only 2 parameters. The first one is the package name, as before, because it uses the same process, so it's out of your application process. And then you write your interactions in a Lambda parameter. So here we basically can write the same interactions as before. So we write press home and start activity and wait, which will cover basically the app startup critical user journey. And then you should always cover, like in other interactions, like the most critical user journeys in your application. So in our case, you'll be waiting for the same content to show up on the screen, like using the device wait, find object. And then we can, for example, as the screen is loaded, we can scroll the list of the items, and that's it. That's our generator. So once we run the generator, it will basically collect the methods and classes that were called during the execution of that test. And to run it, even though that it's the same library, here is a little bit different. So we run benchmarks on a real device, but we need to run the baseline profiles generators on a rooted device for now. And we can use an emulator for that. But instead of manually setting up an emulator, tearing it out, we can use a new Gradle feature called Gradle Manage Devices. So how does it look like? What does it do? So basically, when you run any tests with Gradle Manage Devices, Gradle will take care of creating the device, setting it up, downloading the image. You don't have to take care of anything. Then it will run the tests you specified. It will copy the results to your hosting machine, and then it will tear down the emulator, the device. So again, you don't have to take care of the manually of setting up the emulator. To start with that, you specify in the build Gradle file, within the test options block, you specify manage devices, and within that, you specify the name of the device you want to use. So here it'll be Pixel 2 API 31, but it can be my awesome Gradle managed device. And then you need to tell there what type of block it is. So here it is managed virtual device. And you specify the details. So device will be Pixel 2, API level, and then system image source, which is AOSP that is capable of running in a rooted mode. And then, the details. And then you can run it. For now, you need to run it as a Gradle task. Gradle will basically create the tasks for you based on the specifications. So here we see that it'll create the task Pixel 2 API 31, which is the device name. And then it'll need to know the build variant of your application, which is benchmark. But if you use build flavors, it will be demo benchmark, server benchmark, production benchmark, whatever flavors you have, and then Android test. If you run it, then it would run all of the tests within a module. But what we can do is we can use an instrumentation argument to filter just the baseline profile rules. So we'll use Android X benchmark enable rules. We'll specify baseline profiles, and this will filter out every test and run just the baseline profiles generators. Okay, we'll run the task. It will execute the instructions we've specified, and then we need to apply, and then it will copy to the hosting machine, and then we need to apply the profile. So basically, I was saying, it will provide the output in the build folder. So we copy that file, which is the name of the class name and test, and paste it into the source/main folder, just next to your Android manifest. And we rename it into baseline.prof.txt. There's one more thing we should do, and that is we need to add a profile installer dependency. Profile installer allows to pick the generated file locally at installation. And it helps with local testing and benchmarking to measure effectiveness. But also, it supports platform versions that don't work with cloud profiles, which is Nougat and Oreo. And there's one more feature, is like if you don't distribute your application with Google Play, it can support the devices that don't have the Play services. All right, so we've added that, and now it's time to measure effectiveness of our baseline profile. Does it even work? So for that, again, we can still use the same Jetpack macro benchmark library, staying within the same module. We just basically need to tweak the startup test we did before. So there's one more parameter we can specify to measure that, and that is compilation mode. And compilation mode allows to specify three things. Either it's none, which means that there's no pre-compilation into machine code, no ahead-of-time compilation happening on the device. Then there's partial, that will basically pre-compile the application based on the rules we specified with the baseline profile. And then there's full, which will fully pre-compile your application into machine code. Full is only available on older devices, like Marshmallow and Lollipop. That only is like every application is basically ahead of time compiled. So in our case, we can use none and partial. So let's do that. We specify the parameter in the method, in the startup method, and then we write two tests. Startup no compilation, that will use the compilation none, and partial, that will use the baseline profiles. And that's it. We can run the test, again, this time on a physical device, ideally, because we're measuring, and we'll get results. So here we can see that for the time to initial display, the baseline profiles, the one that we run the compilation mode partial, took 15 milliseconds shorter than without it, which is like 21% improvements just with like couple of lines of code. So now that we've improved the performance for everyone, let's keep it that way and let's monitor the performance.
Thanks. So yeah, you now know what to do to inspect your app's performance and how to improve it using baseline profiles. And well, you want to know whether the optimizations that you've made actually do what you want them to do. So that graph of app startup time actually still goes down instead of going up. And this is why you have to monitor. In order to monitor your application, there's two types of metrics that we're looking for. One of them is field metrics. Field metrics are things that you get to see in the real world, also known as production monitoring. It runs on real devices with real users. So this means there's a lot more variety than you have locally, because there's a lot more variety of devices and platforms out there than most of you have in their own setups. And also gives you real user behavior, because users might use your app in ways that you have not really anticipated. And they also might use flows in a way that you might find unexpected. And you see all these things with monitoring in the wild, with field metrics. The other one is local metrics. Local metrics is essentially everything that you see in your lab setup, on your development machine, or anywhere that you have locally before you ship it to your users. So that gives you early performance data. It's limited with the users and devices that are available, but you can use this as a go or a no-go signal. So if the graph goes down, if you want it to change, that's good. If the time reduces, that is a go signal. If it goes up, you probably want to go back and see what you have done and maybe roll back some things before shipping it to users. So that is also being able to mitigate any damage that you might be doing with performance without looking for performance. These two metrics have a lot of ways that you can set them up. There's a couple of things that we can give you for free as well. So let's take a look what we can do. When you prepare a release, you gather a lot of metrics to test and benchmark, as Thomas just explained to you. And then you release your app. And after that, you gather the field metrics. Field metrics, there's a couple of things that we can do without you having to do anything. So let me introduce you to Android Vitals. Who here already has access and uses Android Vitals actively? Quite a few. Kind of how I expected, that's not everyone, but there's a lot of things that Android Vitals can give you for free. And in order to use Android Vitals, all you have to do is upload your application to the Play Store. Google Play then takes care and does its magic with Android Vitals, and it gives you a lot of data. It gives you data on app startup time, slow and frozen frames, unresponsive activities, crashes, excessive wake-ups, stuck wake logs, and even permission denials. So that's a lot of data that you get for free from the field, and you see how your users are using your application. You get a nice dashboard where you can see what's going on, where you see how your app is performing, even to other apps in your category. So Android Vitals gives you all this information for free, and you don't have to implement anything within your application other than uploading it to the Play Store. If you want to go deeper, but this information is sometimes a bit vague and a bit wide. If you want to go deeper, there's Firebase Performance Monitoring. To use Firebase Performance Monitoring, you have to do a little bit of coding, but to get started, it's literally as easy as that. All you have to do is to add the Firebase perf dependency as a Gradle plugin to your application. This allows you to measure cold startup times, gives you information on slow and frozen frames within activities. Also, network requests can be covered for popular libraries, and it gives you usage duration stats as well. Still very wide, it's good information, but it's still very wide. So if you want to go deeper and make sure that you get more specific data, you can use the Firebase Performance dependency and use it within your application to start tracing what you're doing. So similar to the tracing that Thomas introduced, you have a new trace, and you use that trace and run code in there. All the code that is run in there is being traced, is being tracked, is being sent to Firebase Performance Monitoring afterwards. That's one way for call sites to see what's going on, but even if you have a function that you always want to have monitored and always want to have tracked, you can use the annotation, a trace, and add a trace to every single call of that function. So every time some data is being loaded from remote, that is traced, and you get the start and the end times and see how long it takes to load that data from remote in order to get some information from that. And all of these give you a wide variety of data on a lot of things. And let me talk a little bit about one more thing, which is jank. And jank, for janky frames, so slow and dropped frames, we have a library called JankStats. It's currently in alpha, and it enables you to track and log every single janky frame that your application might have. In order to use it, you say JankStats create and track, and install it to the window that you want to monitor. If you have a single activity, then this is it just in your activity on create. You can create this, and then you can check every single frame if it is janky. And in that janky frame, you can log this into your reporting queue. But if you just say, like, hey, there's a janky frame, that wouldn't be very helpful. And this is why we have the possibility to add more data to this with a metrics holder, so you can see exactly what was going on. And you can add any state as a key value pair. So if you're using navigation, you can add the navigation as a key and add the destination as the state for that, and as a value. So it means that every time there's a janky frame in the navigation with a destination change, you see when this happened, what happened, and at which destination this happened. But you can add even more. You're not limited to a single state. So if you have a lazy column in Compose, what you can do is you can remember the metric state holder and your lazy list state and pass those into a launched effect to keep things off the main thread. And then when the list is scrolling, you can add the state that the list is scrolling, and Django occurred there. Scrolling in a scrolling list or scrolling columns is a case where if you don't implement loading correctly and performantly, then sometimes jank occurs. So this is a very good spot to add your jank tracking and jank metrics in there. And then once it's done scrolling, you can just remove that state again. This is what you would see in your reporting. You would see some timing metrics, and you would see there is jank at these states, and you can reproduce it here. So you can go to the point where this jank occurred, and you can try and reproduce it locally. Which leads us back to local monitoring. All of these things that you've just seen are things that you can do in the field. And from local monitoring, again, those are things that you're doing before releasing. And one of the things that you can do to automate this, because automating things makes your life easier, and you only have so many hours in a day that you can actually do work and do things. That's setting up a CI server that can run things like this, automated, without you having to push the play button, the run button, without you having to make sure that all your colleagues have the same setup. You have this one server, which is the source of truth. You can run benchmarks before every release, and you should run every test and benchmark at least before the release, maybe even after a commit went into your main branch. And you can compare these results over time. Comparing results, though, can be a bit weird, because if you have a build and you see, like, how long does a build take? How long does a performance test take? Well, there might be things like this. So why did this happen? And if you compare just one build to another, you see that there is a regression, and if you just say, let's see if the one build was faster than the other, you might see, oh, there's a regression in here, just down there where it goes up. Actually, that might not be, because this might be just a bigger picture. If you take a look at that, then there's just like a dip in here, which might be because resources have been gone unused. Maybe there was something else being used on that machine for a while. That service got taken down, and this gave you your CI server more power to make your build. And a lot of things why this could have happened. But essentially, well, you don't really know whether this part is a performance problem or not. And in order to see this, as a human, it's kind of maybe not really obvious, so let me add this line. So you see that the line goes up slightly. So you see there is a regression, and performance gets worse. But you don't always have the time to look at this graph and say, like, oh, this is going on, and you can't really see this. So we have a thing called step fitting. Step fitting is a method to just take a look at a couple of builds, aggregate the data, and then compare this to another part of the builds. So we'll take a look, see what's going on before that, and also after that. And you see in between there is actually a regression. It's not at the bottom of the pit, but the regression is at the top. I know that this is already a lot to get stuff set up and everything, so if you want to learn more about step fitting, which is pretty awesome, take a look at this article. It's great and goes in much detail, and exactly the algorithm that you can do that we're using for Android X as well to make sure that the performance of the libraries goes down. Performance goes up, graphs go down, and we make sure that you can use that as well within your CI server. We also have guidance on CI servers available. And now, this is everything that we wanted to talk to you about today. And now you know how to inspect, improve, and monitor your performance, and how you get started again with this. So this is why it's the modern Android performance cycle. And with that, I just wanted to leave you with a couple of bits of more information for you to learn. We have a new and updated hub for performance, which is developerandroid.com/performance, where you'll see all the things that we talked about today and more on improving and inspecting and monitoring your application's performance. We also have samples available that you can take a look at, that you can play around with, things that you can use. We actively develop them, actively monitor them. If you want to contribute to them, let us know in the issues there as well. And we have this new sample called Now in Android, which we are working to make sure that all the things in there are performing well, that we use all the best practices, showing you how to use the libraries that we just introduced. Because we're at DroidCon, we also have a code lab tomorrow. This code lab, you will be able to implement the baseline profile yourself. You will be able to set up benchmarking. We have code for you to play around with that. Or if you're there to bring your own application to implement a benchmark or a baseline profile, please bring it. We're looking forward to that. We'll both be there and help you through that process. If you want to talk more about performance with us, we'll be at the booth now and also from 2:30 this afternoon. And with that, thank you very much.